Wait, what? No, now I gotta ask you a question.
Okay.
So the latest picture you posted, you're saying the picture in the middle. Wait, which is the vertically stretched one? Which one did you uncompress?
The one on the left. It's just from the picture above, but I just took and I stretched out the bottom of the building back to its proper size to show that you can still see the fence in there a little bit. I mean, it's kind of muddied because it was pretty compressed, but
So the bottom left was compressed and you vertically stretched it to make it match the observation on the top right.
right. Well, I just
Okay,
stretched it back out to its original height.
right. So the bottom left, the newest image on the bottom left, that has been stretched out.
Right, from the picture above it on the
Yeah,
left.
so it's just compression. That's not bottom up obstruction.
Right, right, exactly.
Nice, no earth curve.
Well, you can't say no earth curve because water, which is below eye level, is appearing above eye level. So, because those crosshairs are set straight and level. So, if Earth is flat, then the light is curving, or if the light is straight, then the Earth is concave on that one day, but not on the other day. So we could go for rubber Earth that changes from concave to convex depending on the weather. That's got kind of a bouncy ring to it, the Rubber Earther Society.
No,
Well,
what?
just
No.
initially, I like it. Thought of pure ridiculous.
The
This is
globe can just do
hilarious.
whatever
A
it wants. The
rubber.
model is truly expendable. It's just throw make it rubber or whatever. It doesn't matter.
Jesse, you're showing a magic trick. What do magicians use? Smoke and mirrors.
You can go do this experiment yourself and you'll see I didn't fake a thing. All you gotta do is...
Okay. Was there any mirrors, Jesse? Was there any
What's
smoke?
that? I didn't see any smoke or mirrors.
Oh, okay. Let's see. Define smoke and define mirror.
Well, let's see. Smoke is what comes out of Alan's ears when he finds out that the celestial theodolite doesn't predict the star timings correctly, and mirrors is what he holds up to
Define
try to
smoke
cover
now.
it.
Okay. Smoke is why all the footage from the 1970s basketball highlights look like they do because everyone was smoking cigarettes in the stadium, right? And there was a bunch of little particles in the air, right? That block the light, that move the light. That's why it looks that way. Now, define mirror.
What Alan holds up when he discovers that the celestial theodolite doesn't predict the flat Earth results.
So a mirror shows you yourself, but reversed, right? Mirrored right down the center also, or not. It will show you exactly what it sees back to your eyes, right? So the
Well,
ocean or the body of water that we're measuring over is a mirror when the sun's up, right? Do you concur?
I mean,
And
there
that
are...
dependent on the day, as you say, the Earth is fluctuating back and forth between convex or not convex, but definitely not flat, right? So that is depending on how many particles are in the air, right? So you're a great magician, I'll tell you that. But your trick's been found out. Hey, Electric, can you define trick?
An illusion.
No. A trick is something a whore does for money.
Okay.
How much do you think we
Or
got up?
refer to the whore itself as the trick.
I'm gonna trick you out and put you on the track. So did Jesse just bail or what?
I don't know. Oh yeah, he left.
Yeah, the magic show's over, boys. How much do you think he's getting paid to show us that trick? Who's his pimp?
You know, light's gonna bend however much it needs to, depending on the size of your ball. You know, if your ball is bigger than 3959, then your light's gonna bend at a different rate. That's what I was getting at with him, and he just doesn't want to talk about it.
When you say 3959, you sound a bit mentally challenged.
All right, you want to talk about whores again?
Well, let's get into arc seconds and minutes and micro nanoseconds.
Have you ever heard that the 3959 is not just the radius of the globe, but it's also the radius of the spherical limit of your vision?
And that's why when Jesse's in here, we didn't say once, unless Electric or Jeremy were talking, and he was the only one to say, why we see so far? Why do we see further? And this is why. The smoke and mirrors, the magic trick.
The magical refraction that happens on with every atmospheric condition on Earth that allows for the observation to take place. Could be dry as hell. Oh, perfectly curved. Well, you get a little bit here and there, like with the picture you were showing where it compresses and stuff. But nope. Doesn't matter what the conditions are, or you could be in the desert, you could be on a frozen lake in Canada. It's always the same.
What condition is your condition in?
I heard that song was about Scientology. Word, go ahead.
So, yeah, you saw my drawing, right? So, you know, we're considering there's boundary layers, there's different mediums, right? As you gain altitude, the density is less and less, right? Atmospheric pressure drops with altitude, right? So if I'm angling a laser horizontally, right, and you got your pressure gradient bending around a globe, then, you know, at some point along the path of light that's supposed to be traveling horizontally, because light doesn't bend unless it interacts with a new medium, right? So I consider my light ray as traveling straight until it interacts with a different medium. So the medium that it interacts with is less dense on a globe. Like if I'm firing horizontally, then the light ray is going to actually end up hitting the layer of density directly above it. Jesse says this is going to reflect the path of the light back down towards the denser medium. That is just going to stay trapped within that layer, causing it to bend around a ball.
Yeah, I see what you're saying.
Yeah, it's pretty much like, it's like a duct.
Yeah, there you go. That's a great way actually to really fix the helicopter thing I was trying to show you. So let's say the helicopter's got a laser on it too, and you're shooting one laser to the observer from the surface, and you're shooting one laser from the helicopter, but your aim point is exactly the same, or the place that the laser will hit is. Do you see what I'm saying? There's one laser going to the observer over the surface, then there's another one coming to the observer's eye, intersecting that same path at some point. where you'd see them both in the same place because of the refracted position from the globe one.
Yep. And when things are in the sky, they're not subject to the same medium as things that are supposedly below the ground.
Yeah, this is strangely something that I spent a lot of time meditating on early in my flat Earth journey because of this exact argument. Like before I was like, had really thought it through. This is one of the things that I spent a lot of time on that bothered me. Because I was like, how the hell are you seeing something bent from a different position while you're in one position? You'd see overlapping images, or you'd see a really messed up distortion at some point that would be apparent like all the time. You know?
Yeah, exactly.
But it's
So
never.
yeah,
No, I was just gonna say the only thing that ever distorts is really close to the surface. You know, there's always that really steep angle that you're looking at across the surface. And there's also bottom-up obstruction on a flat surface for the same general optical reasons that they're actually describing. It's just that they're nowhere near, they don't have nearly the effect that they say they do, you know? Sure, light bends, yeah, of course it does. It distorts as it passes through a medium, there's no doubt about that. That does make sense though, the two lasers, laser from the helicopter and laser from the terrestrial.
and you know, at some point along the path of light that's supposed to be traveling horizontally, because light doesn't bend unless it interacts with a new medium, right? So I consider my light ray as traveling straight until it interacts with a different medium. So the medium that it interacts with is less dense on a globe. Like if I'm firing horizontally, then the light ray is going to actually end up hitting the layer of density directly above it. Jesse says this is going to reflect the path of the light back down towards the denser medium. That is just going to stay trapped within that layer, causing it to bend around a ball.
Yeah, I see what you're saying.
Yeah,
Well,
it's pretty much like, yeah, it's like a duct.
Yeah, there you go. That's a great way actually to really fix the helicopter thing I was trying to show you. So let's say the helicopter's got a laser on it too. And you're shooting one laser to the observer from the surface and you're shooting one laser from the helicopter, but your aim point is exactly the same. Or the place that the laser will hit is, do you see what I'm saying? There's one laser going to the observer over the surface. Then there's another one coming to the observer's eye, you know, intersecting that same path at some point where you'd see them both in the same place because of the refracted position from the globe one.
Yep. And when things are in the sky, they're not subject to the same medium as things that are supposedly below the ground.
Yeah, this is strangely something that I spent a lot of time meditating on early in my flat Earth journey because of this exact argument. Like before I was like, had really thought it through. This is one of the things that I spent a lot of time on that bothered me. Because I was like, how the hell are you seeing something bent from a different position while you're in one position? You'd see overlapping images, or you'd see a really messed up distortion at some point that would be apparent like all the time. You know?
Yeah, exactly.
But it's
So
never.
yeah, yeah.
No, I was just gonna say the only thing that ever distorts is really close to the surface. You know, there's always that really steep angle that you're looking at across the surface. And there's also bottom-up obstruction on a flat surface for the same general optical reasons that they're actually describing. It's just that they're nowhere near, they don't have nearly the effect that they say they do, you know? Sure, light bends, yeah, of course it does. It distorts as it passes through a medium, there's no doubt about that. That does make sense though, the two lasers, laser from the helicopter and laser from the terrestrial.
What's crazy is like, okay, so if I angle my light ray horizontally, right? I described the whole thing about the curve gradient around the globe. So the moment that light ray is interacting with that boundary, We're saying that it's going to reflect down and remain within the density gradient that is more dense. That it's literally like reflecting off of the less dense medium and bouncing down to remain in the denser medium. So it's literally a different angle. It's traveling at a different angle within the same medium.
Yeah, I'm totally visualizing what you're saying here. It's like you could use whatever layer you wanted to as some type of, a mirror essentially that you're bouncing right off of it and coming back down in a different direction. Now, here's another question. If I put somebody up in the air that's in a physical straight line from that laser and you shoot at him with the laser, is the laser not going to reach him? Is it literally going to bend away from him and go down towards, I don't see that happening.
It's much easier to just stop presuming all this globe shit and just be like, you know what? Instead of trying to invoke magical reflecting less dense layers of mediums and, light bending around the ball when light's supposed to travel straight at the same time, why not just say that's just not happening? It's so much simpler.
There's implications. Implications that I think are well known.
But what about the Mercury? Like, dude, yeah, what about it? Like, it has nothing to do with what we're talking about. But there's other things that tell me Earth is a ball.
I'm just wondering, like, okay, so does the beam get split like in a half mirror? Like in laser interferometry where the, part of it's refracted and then part of it isn't? Yeah, I don't think so.
Jesse said he's going to disassemble a theodolite live on camera, dude. I can't wait for this. We're going to find out how well collimated lenses are with these NASA-built theodolites.
Yeah, it's interesting. If I remember correctly, there's a clear deviation between the transit level and then the actual theodolite.
Yep.
And the reason for that, people ain't going to like it, but they may have fudged with the instrument to give you a number that makes you think it's a globe. But when you use a physical, actual transit level, like Dr. Heffron did, you get the actual angle. This might be an interesting topic for some people that they've never heard of.
Oh boy, you're bringing up Mike Heffron. I'm not about to talk to him. I want to talk to him, not about it.
Word.
This presentation will actually be omitting some things because I want to focus on some lies that are being told, some misdirection. There's a lot of that going on, and I'm not going to cover everything necessarily that I wrote in this document, but you can find this document in the chat. It's called "Where Does the Truth Lie?" From the point of view of our globe Earth friends, the circumference of the globe is just the circumference of a circle, which is 2 pi r. And for any 2 points on Earth, there's a great circle that allegedly intersects those 2 points. And it's easy to find the radius of that by using the calculators I have links to in the document. So if you go to the actual document, you can actually click on those links and it'll take you right to the website. This is very important to our globe Earth friends because they're often conflating distance with angle. And we'll kind of get into why they're doing that. But basically, they want distance to represent the alleged tilt of the Earth, which I call theta sub d. And that's just the distance times 360 degrees divided by 2 pi r, whatever r is for those 2 points you're trying to find the tilt between, the alleged tilt between, which is really distance. And then I give the example of Pikes Peak. Actually, I give an example of an average 6371 kilometer radius of the Earth over a distance of 111.2 kilometers, which is the 69.1 miles per degree that everybody has probably heard talked about endlessly. And for example, at a particular location near my house, and I apologize for little small discrepancies in this between what Shane presented and what this is saying, but at the beginning, I always used Movable Type's website to get the distances, and they say Pikes Peak is 50.7 miles from me. Jesse suggested a more accurate NOAA website, and they say it's 50.612 kilometers from Pikes Peak to my house. In any case, that represents the tilt of 0.455 degrees, which is 27 arc minutes. So we're going to focus a little bit more on globe Earth philosophy before we get into how they're using this to lie to us. But we call this science according to the global positioning system. The height above the reference ellipsoid at the summit of Pikes Peak is 4.3 kilometers. So Shane showed 4.299. That one meter difference doesn't make any significant impact on the calculations. And also, I say the elevation of location near my house was 2.074 kilometers instead of 2.703. That also makes no significant difference. And then either way, you get a rise of the peak of 2.226 kilometers from me to the peak. So that's the rise, and the distance is the 50.612 kilometers. So if the Earth were flat, the arctangent of that rise over that run would be the plane trigonometry angle of 2.5185 degrees, which is 2 degrees 31 arc minutes. So most of us were indoctrinated as children that the Earth is the globe, and so we're expecting the Earth is going to tilt away from us by that amount. And because of that, our globe Earth friends insist that Pikes Peak should appear to be 0.201 kilometer lower for an observer who's 50.612 kilometers away. And they often call that a d squared over 2r drop. So that's globe Earth terminology. So in other words, Pikes Peak should appear to rise not the 2.226 kilometers that flat Earth would predict, but only 2.025 kilometers above the observer's altitude. And so the arctangent of that rise over run is an angle of 2.2912, which is 2 degrees 17 and a half arc minutes from the observer's location. And that just happens to be the very angle a so-called trained expert measures using a terrestrial theodolite. And I have a little diagram of that there. And so I'm saying, well, that settles it then, doesn't it? But inquiring minds have a few questions, because what our globe Earth friends want to downplay is, why don't theodolite manufacturers certify that angle as accurate to infinity and beyond? Because they don't. They say their theodolites are accurate to a few hundred meters. And why would an expert claim a level of accuracy that's far beyond the range of the theodolites? Well, because of that controversy, I decided to perform an experiment of my own. So I went on eBay, found an old David White 8300 level transit, which is a type of theodolite, for $65, and that included shipping. And I decided to measure Pikes Peak. So that particular level transit's only precise to plus or minus 5 arc minutes. But that was more than enough to distinguish between the flat Earth, the globe Earth prediction of 2 degrees 15 arc minutes, the closest that level transit could measure it, and the 2 degrees 30 arc minutes that globe Earth would predict. And to my surprise, that old theodolite measured the flat Earth angle right out of the box. And I began researching, and there were several problems. Of course, the first problem was that within the precision, that measurement was within the precision of the 8300, but was far beyond the certified range of accuracy for that model of theodolite. Actually, that's far beyond the certified range of accuracy for any theodolite. They just don't certify theodolites to be accurate to many kilometers. They generally certify them to be accurate to hundreds of meters. And then secondly, only an expert can use a theodolite correctly. And if you dig into that, you'll find it's very hard to correctly use a theodolite. And then the experts got to compensate for refraction. And the big red flag for me is that refraction is unstable. It comes in many forms, and the experts contradict each other about how to determine its magnitude. And over the past many weeks, Ellen's been doing a really good live demonstration of how globe Earth people cannot agree on what the correct value of refraction is. In fact, you find them contradicting each other all the time because they made it so complicated, even they no longer understand the concept. So I had an idea: what if I bypassed the whole refraction problem using a celestial theodolite, find the elevation of the background stars that are occluded by Pikes Peak? Because we've got this constant movement of stars that are being occluded by the peak all night long. And so I should have been able to easily test the null, and I'm going to gloss over what a null hypothesis is. But basically, if you have a hypothesis that the Earth is a globe, you want to refute the null hypothesis, which is the opposite of what you believe. So if you believe the Earth is a globe, the opposite of your hypothesis, null hypothesis, is that the Earth is flat. In other words, the Earth is not a globe. And if the Earth was flat, that angle should be 2 degrees 31 arc minutes. If the Earth were a globe, that angle should be 2 degrees 17 arc minutes, and that's or at least it shouldn't be 2 degrees 31 arc minutes, and then that would allow you to reject the null hypothesis. So that's the same thing Shane showed a really good diagram of. So I had Gemini AI generate this drawing of a mountain peak occluding a star, and this is showing my basic concept. At the time of occlusion, the shadow of the peak falls on the observer, because that starry light was hitting the observer's eyes. As soon as the peak interrupts it, the observer is now seeing the shadow of where the star was. And it doesn't matter what that angle may be for the observer. We're taking no measurement, but I show a protractor up on top of the mountain because you can take that measurement indirectly up the occlusion time in Stellarium or your favorite astronomy tool of that star you just saw occluded. And that works because the angle of the starlight and its shadow are congruent angles. So those are known precise angles measuring only at the peak and nowhere else. This has nothing to do with where the observer is. Distance to the observer, the rise of the peak, that all comes into play later when you want to see if that was a globe Earth or a flat Earth angle. But the actual measurement, just as shown in the video that Shane played, is just you see the star disappear behind the peak. You have to identify the peak, you have to identify the star, and you have to have the time. And on that particular video, the video was time stamped, but you could do that with a chronometer or stopwatch, or the best thing for anybody who wants to do this themselves, take a video of it and share it with everyone, and let them know what peak it was. Let them know the location it was observed from, so they can verify it for themselves. And there's a lot of eyes on these videos, and that also helps to make sure that you properly identified the star, you properly identified the peak, etc. For some reason, our globe Earth friends are pretending to misunderstand this simple concept. Some of them call it rubbish. Far too many of them just outright lie or start spewing logical fallacies. And that could be either deliberate, or it could be merely insufficient intelligence to comprehend this. But this is not a difficult idea to comprehend. You're citing background stars, and what we want to see is the true location of that star. So analysis using the celestial theodolite is just as simple as finding the occlusion time. And this is a little diagram that kind of illustrates what we're doing. And this is an example for Pikes Peak. So for Pikes Peak, it's 50.6 kilometers away. It rises, according to flat earthers, it rises 2,226 meters. According to globe earthers, it rises 2025, appears to rise 2025 meters, and that's because of the 201 meter drop. So that results in a difference in angle. So for flat earthers, the angle would be 2 degrees 31 minutes. For globe earthers, the angle would be 2 degrees 17 minutes. So the object of a null hypothesis is 2 degrees 31 arc minutes. Is the one angle it can't be. That's what you don't want it to be if the Earth is not flat. Well, my very first occlusion, which was 6:43 p.m. Mountain Standard Time on January 27th, and that was just as close as humanly.
Dr. Mike,
Are we losing
him?
him? Or you stop pushing to talk?
Oh, did you lose my audio?
Yep.
Yeah, cut in and out a couple of times there.
So this may be a network issue of some kind, because I haven't touched the talk. What's the last thing you heard that I should back up to?
I think you were just talking about the first occlusion time and how you're able to achieve it.
And actually, I'll make sure the mic is. This is a noise canceling microphone, so it's possible that was causing me some issues. So the first occlusion I ever observed was at 6:43 p.m. Mountain Standard Time on January 27th, and at that time, Pikes Peak occluded the star 39 Aquarii, and according to Stellarium, that was an angle of 2 degrees 31 arc minutes. And that was as close as I could get with my C-Star S50 telescope, and I had that set for 1 second exposures at 1 frame per second in its scenery mode. And because this is important, and this is one of the things our globe Earth friends like to create a lot of confusion about, because the mountain peak itself was physically occluding the star, refraction was not an issue on my side of the peak. It doesn't matter where the peak appeared to be. It doesn't matter where the star appeared to be. Only the peak could have physically occluded the starlight. So that eliminates refraction from the observer side of the peak. Next, I looked up the uncorrected elevation of 39 Aquarii using Stellarium at that time of occlusion, and that made refraction on the other side of the peak also not an issue, because when you have atmosphere off on Stellarium, it tells you the true position of the star, not where the star appears to be. Well, this was not at all a popular experiment among my globe Earth friends, so they began making all kinds of arguments. The first one I heard is you can't measure from where the observer isn't. The next argument I heard is refraction is real, so you can't ignore it. Early on, they were saying, "Oh, this is just a coincidence that it occluded the star at a flat Earth angle." And at that time, I had only done that one peak, so we didn't know that they were all occluding at flat Earth angles yet. But those are all fallacious arguments. And what's happening over and over again, and this is why I wrote this particular PDF, is we're getting a lot of half truths from globe Earth advocates who are just spouting nonsense hysterically. The best
Ed, you want
argument
water?
they say that again.
That's
You're
my
not
fault. I
making
was not
these?
miking. Yeah, my bad.
Oh, sorry.
No, that was my fault, Dr. Mike. I apologize.
Yeah, no problem.
Sure.
The most coherent argument our globe Earth friends have is that you need to subtract the alleged 27 arc minute tilt of their globe Earth from the 2 degree 31 arc minute elevation of the star occluded by Pike's Peak. And when you do that, that explains their 2 degree 4 arc minute uncorrected elevation of the star at my house, because they want to keep moving the measurement back to my house. And the reason they want to do that, they can then start claiming refraction. And what started this whole experiment is their value of refraction kept changing. Just like you've seen for the past few weeks and everything Alan's going over, they're just constantly throwing out different values of refraction. No matter what value you use, it's always wrong. But they want to insist that we're never using the right value, and that's why Alan went to the method of back deriving the distance, back deriving the rise, to show you their angles don't work no matter what refraction you allow them to use. But conveniently, they always fix everything with refraction, and that elevates it to the angle that they claim. Well, more than they claim, terrestrial theodolites actually do measure that angle, and that's all an optical phenomena. And I don't really go into that in this paper, but they're trying to argue optics, appearances, and the whole purpose of this experiment was to eliminate the constantly changing refraction corrections and to positively identify, is that star occluded at a flat Earth angle or a globe Earth angle. So with all their tilts and refraction corrections, my globe Earth friends have managed to make everyone forget that the occluded star was somehow at the flat Earth angle relative to the peak without any need for any of their tilts, no need for refraction adjustments, without knowing where the observer was. Now they need to know all of those things, and they have to make refraction corrections on top of that to come up to validate their point. This method doesn't need any of that. It eliminates refraction from the picture. It eliminates all the nonsense they keep throwing in to confuse everyone. So not only did my globe Earth friends fail to refute the null hypothesis, they actually validated that the hypothesis that the Earth is flat is true by demonstrating that all of their globe Earth angles are just derived from tilting and refracting the uncorrected flat Earth angle the celestial theodolite finds for the starlight occluded by the peak. So I want everybody to think about that. And I've actually switched to, because in the beginning I was trying to humor them, and Shane showed a good early diagram where it showed that the flat Earth prediction is right between their two extremes, with refraction and without refraction. We're always closer to right on than they are, and yet they consistently claim the opposite because they manipulate refraction until they get the number they want. Well, I've started using a new method, and this graph shows that new method. And I do this because my globe Earth friends, they're lying about what the celestial theodolite is doing. They need tilts and they need refraction to fix their numbers. They need lots of logical fallacies to make their points. When you look at this graph, it kind of eliminates all of that. This is the logarithmic scale on the graph, so that if you know anything about logarithms, you never show 0 on a logarithmic graph, and that's because 0 is undefined. It's infinitely far away. It's like the Zeno's retelling of the Achilles paradox, where the world's fastest runner in a race against the tortoise gets closer and closer and closer, but never beats the tortoise, because no matter how fast he runs, the distance keeps changing and it gets shorter and shorter. Well, so 0 is a perfect globe Earth prediction, and if the globe Earthers were right, all of these gray bars on this graph should be at 0. None of them are anywhere near 0. And the blue bars on this graph are the flat Earth prediction, which is always some number of seconds different from the globe Earth prediction. So where the globe Earth prediction is 0 seconds of deviation, the blue bars show what the flat Earth prediction is, and the gray bars above or below those blue bars are showing what the actual observations were. And you can see, contrary to what our globe Earth friends are saying, everything here is a really, really good match to what flat Earth predicts, and it's not even remotely close to globe Earth predicts. And this technique begins with just a simple step. Take a time-lapse video of a mountain peak occluding stars. And it's essential to know when the video began and the duration of each frame of the video, and that lets you accurately determine the occlusion times. And then the video also helps document the experiment and helps you identify the occluded stars. And when you're having, some people have trouble identifying peaks, and I put a link here to a peak finder website that'll help you identify the peak. And then whatever steps you take after that depends on what you want to know. For this particular graph, what I wanted to know is the actual and predicted occluding times. And to find those, the extra steps I took is I just calculated the predicted flat Earth and globe Earth angles. So one with a drop, one without a drop for each peak. And then I looked up in Stellarium what time each observed star was at those two angles. And then I calculated the difference and plotted that on the graph. So, and anybody who wants to verify all that data and the calculations, out there is a spreadsheet called Coffee Table 2025-08-07. It's an Excel spreadsheet. It's actually saved from Google Sheets, so it's a Google Sheet save of an Excel spreadsheet, and you can refer to that spreadsheet to find any of my data and any details of the calculations. And so this is pretty simple, and I hope interested people will take the time to read this PDF and understand the devious tricks that are being used to try to lie about what's happening here. And that's all I have to say about this.
But your trick's been found out. Right? So you're a great magician, I'll tell you that. But your trick's been found out. Right? So you're a great magician, I'll tell you that. But your trick's been found out. A trick is something a whore does for money. So did Jesse just bail or what? Yeah, the magic show's over, boys. How much